Hello everyone, my name is Aarohi and welcome back to my channel. So guys, today's lecture is based upon the previous lecture where we understood what query key and value is. So today we are going to cover how to calculate attention scores. But first, let me just give you a quick recap of what we did till now. So first we learned how to prepare input for transformers. And for that, first we used a tokenizer to break the raw text into tokens, and then tokenizer assigned a unique ID to each token. After that, these token IDs were passed into the embedding layer, where embedding layer created a vector for each token. And after this step, we used positional encoding to add the position information of each token. And for that, we created a positional encoding vectors for all the tokens. And then we performed element-wise addition between the embedding vector and the positional encoding vectors. After this step, our input is ready for the transformer. And guys, we are talking about which paper? Attention is all you need paper we are discussing. And the main task of the transformer starts with the encoder. And the main job of encoder is to learn how words relate to each other. So to learn the relationship between the words, encoder use query key and value. This is what we discussed in previous lecture. So for that, each token perform three tasks: query, key and value. And guys, if you don't know what query, key and value is, then please check the previous lecture because then only you will understand today's lecture. We also discussed in previous class that you cannot calculate query, key and value directly. You need weight matrices for that, and we created three weight matrices. One weight matrix for query, key and value. And then we used these weight matrices to calculate the query, key and value for each token. And these are the three weight matrices which we initialized randomly, and these values are learned epoch by epoch. And I have shown you the example with one token for token love. So this was our input sentence. From this input sentence, we took the token love, and I have explained you how to calculate query, key and value for token love. And in the same way, you will calculate query, key and value for all the tokens. So this is the query, this is the key, and this is the value for token love. And this is what we used to calculate this. Today, we will continue from here. So far, we have calculated query, key and value for all the tokens, right? But still, your encoder does not know which words are important. So now the next task is attention. Today, we are going to start with the actual attention calculation. With the help of attention calculation, your model will know which words are important. So let's see step by step how to do that. So the first step is to take the dot product of query with the key. What it means, let's see. So let's see it with the example. We will take the same example, the token love. Okay, so we calculated the query, key and value for token love. So we will continue with that example only. So now we will take the dot product of query token with the keys of all the tokens, including the love token. Means the query of love token will be multiplied by the keys of all the tokens, like this. You can see here, see, query of love token is getting multiplied by key of my token. Query of love token is then multiplied by the key of name token. Then it is getting multiplied by a key of is token, Aarohi, and I love coding. So keys of all the tokens are getting multiplied by the query of love token. So in the same way, you will perform the step for all the tokens. Right now, I'm just showing you for the one token, token love. In the same way, you will multiply the query of each token with the keys of all the tokens. And what does this mean? This means the query of love token is asking, how much do I match with other words, or how much do I match with this word or this word? Okay, so each dot product gives us one number. And if the number is large, it means words are more related. And if the number is small, that means words are less related. So let's see it practically. Let me show you the calculation of attention score of query of love token. So the query of love is this, and the key of love is this. And now we perform the dot product. And dot product simply means that we multiply the corresponding elements and then we add them. So this is the formula. Now you substitute the values and this is what you get. So you got one value, which is 0.80. So the final result is query of love when you performed dot product on query of love and key of love, you got this 0.80, right? So this value represents the attention score, means this tells that how strongly the word love is related to itself. So for this love token, we will get 8 numbers because we have 8 tokens in the sentence. So these 8 numbers will form one row in the attention score matrix. So for row love in the attention scores, we have this. So this means it is giving 5% attention to my token, 10% attention to name token, 60% attention to is, and 25% attention to Aarohi. And like this, these scores tells you how much attention it is paying to other tokens. And after doing this, for all the tokens, for all the words, you will get the attention scores. And this process is called dot product attention. Now let's calculate the attention for one more token. So this time let's take my token. So query of love token, we want to do dot product with key of my token. So now apply this formula, substitute the values and calculate it. You will get this value. Now this value shows how strongly the word love is related to the word my according to the model. So this is the first step. So guys, there is one problem that when the size of query and key vectors, what is the size of query and key vector? What defines the size of query and key vector? Remember DK, I have told you, see here. So this is how we got the DK. DK means how many columns you are going to have in each query, key and value vector. So in query and key vector, how many columns you are going to have, how many numbers you are going to have depends upon the value of DK, right? So when the size of query and key vectors, which depends upon DK, is large, so for example, in our case, 64, right? So then the dot product which you will perform will become very large. And when these large values go into the softmax, softmax becomes very, very sharp and gradients become very small, and you can face the problem of vanishing gradients. So this makes training difficult. So to fix this problem, we scale the dot product. So instead of using it like this, means instead of taking the Q and then multiply it with the transpose of K, what we do, we take the Q key transpose and we scale it by dividing with the square root of DK. So DK is 64. So the square root is 8. So this scaling keeps the values in a reasonable range. And this is the reason why it is called scaled dot product attention. Let me open the paper and show you. Guys, don't worry if you are not understanding what I'm writing right now, because this part, this formula, why I'm performing this query and then why I'm using this key transpose, that part I'm going to cover in detail in some time. Okay, so just keep watching. I can assure you that by the end of this lecture you will understand this topic. Okay, see, this is the paper. Attention is all you need. So scroll down and we will go to the section where they are discussing about this scaled dot product. See, this is the scaled dot product attention, and this is the part which we are discussing, and this is the image related to it. And by the end of this video you will understand what this formula is, because we are trying to understand this formula. We are understanding this part today. By the end of this video you will understand what this formula is, how this formula is getting used, and how we are calculating the attention scores. Now after scaling, we will apply softmax. See, this is the formula, and there, this is the part which we are discussing. We are applying this softmax now. So why we are using softmax? Because softmax convert the scores into probabilities. And after the softmax function, all the values will lie between 0 to 1. Means for each row will give you the values, and if you will sum those values, you will get 1. So for example, for row love, these are the attention scores, 8 attention scores. Guys, why we are having 8 attention scores? Because we have 8 tokens in our sentence and we want to calculate the attention scores for all the 8 tokens. Means we want to teach our model how much attention it should give to each token. So that's why 8 values we have in one row, and if you'll sum these 8 values you will get 1. And this is the part we want to do, and for that we used softmax. Guys, see these attention weights over here. The word is giving maximum attention to the third word because that word have the highest value. So now we have attention weights. Guys, like this we will calculate the attention weights for all the tokens. And till now what we have discussed, we discussed about query and key, right? And we performed the dot product on query and key, and we got the attention weights for all the tokens. Now the next step is that we use these attention weights with the value vectors. And guys, again I'm telling you that right now I'm just giving you a overall idea. In some time we will understand everything step by step. We will calculate all the values step by step and you will understand. Okay, so what is the next step? So next step is to use these attention weights with the value vectors. And how we will do that? We will multiply the attention scores by V. So this is the formula. We will use this formula for that. See here, into V. This part we are using now. So this is the final formula. You can see in the paper, this is the final formula, right? So this is how you can calculate the attention scores. Now let's understand it in detail. So we calculated query, key and values in the last class, and I have explained you what these things are. This Q is a matrix of real numbers, and its shape is, its size is 8 by 64. That means 8 rows and 64 columns. Why 64? Because decay is 64. And in query and key, the decay tells you how many number of columns you are going to have in a matrix. So in query, we have 8 rows and 64 columns. 64 columns simply means 64 values. And key is also a matrix with 8 rows and 64 columns. And 8 simply means the number of tokens. And if you will transpose the key, then you will have 64 rows and 8 columns. But why we are transposing the key? Let's see that part. So I have told you, if you will see the formula of attention scores over there, we are using Q into key transpose. Why key transpose? Let's understand this part. In query, this 8 means number of tokens, 8 tokens, 64 means 64 columns, that means 64 features per token. And in key, this 8 means number of tokens, and 64 means each token has a 64 dimension key vector. If we talk about single token or single row, that means query of love. For query of love, you will have this kind of vector. This vector have 64 values in it. For every token, you have this kind of vector, and when you stack them together in the order of your sentence, then you will get a matrix, right? And what we are trying to compute? We are trying to compute the similarity between the every query and every key. So that means first token query will multiply with all the keys, second token query will multiply with all the keys, third token query will multiply with all the keys, right? So you get a 8 by 8 matrix. So how we are getting this 8 into 8 matrix? Let's see that. So the shape of query is 8 into 64. 8 rows means 8 tokens and 64 columns in it. And the shape of key is also 8 into 64. And if you want to perform matrix multiplication, you need to follow the matrix multiplication rule, which is A into B is only valid if the columns of A is equal to the rows of B. But in our case, the columns, the Q columns are 64 and the rows in keys are 8. So you cannot multiply, right? Multiplication is not possible. So we need to do some change in it. So that's why we used transpose. So transpose simply means we swap the rows and columns. Now we are transposing the key. So right now key is a matrix of 8 into 64 shape. But after transposing, now we have 64 rows and 8 columns. Rows became columns and columns became rows. And we transpose K because we want to compare every query with the every key. Now the matrix multiplication will work because inner dimensions are matching. So you got 8 into 8. Now what does this 8 into 8 matrix means? Each row means one token's query, and each column means the similarity with the another token key. So this kind of matrix you will get. See, this is a 8 by 8 matrix, and this is a query of love, which I have explained you. And in the same way, you will perform for other tokens. Now, let's open the paper and see what all part we have discussed till now. First, let's see this image. So query and key. See, right now we are not talking about value. Value we will talk later. So query and key, what we did, first we perform dot product on query and key, which is happening over here. Then to solve the problem of vanishing gradient, we performed scaling on it, right? And this part is optional, so that's why I'm not discussing this part. So after scaling, we applied the softmax function on it. So this is what we studied, right? Why we applied softmax? So that the in each row, when we add up the values, we get the probability scores between 0 to 1. When you add those probabilities, you will get 1. Okay. So after softmax function, we have q into k transpose over here. Okay. Then we are multiplying the values with it, and you will get the final attention. Okay. So this is the formula we used. Now you know what Q is. Q is query. K transpose. I have explained you why we did this K transpose, because we want to perform the multiplication, and we can perform the multiplication after transposing only. And dk square root. Why we did the square root of dk? Because we want to scale the values, and then we applied softmax on it, and then we multiplied it with the value. This is how you get the attention scores. And guys, this is what we are covering today. In my next video, we will cover the next topic. And guys, please, if this content is helpful, like, share, and subscribe my channel. Thank you for watching.